Click the bell icon to get latest videos from Ekeeda.
Hello friends, in this video we are going to continue with one more problem based on property number 2 of definite integral. Let us start with problem number 13. Integral 0 to pi by 2 sin x upon sin x plus cos x the whole square dx. Again, you can see the given integral is in fractional form. Therefore, we can consider this as equation number 1 first and then use the property. We can write x as upper limit pi by 2 minus x. And we can mention the property integral 0 to a f of x dx can be written as integral 0 to a f of a minus x dx. Sin of pi by 2 minus x will give you cos x and cos of pi by 2 minus x will give you sin x. Considering this as equation number 2, we can add equation number 1 and 2. Therefore, adding equation number 1 and 2. We have I plus I is equal to integral 0 to pi by 2 sin x upon sin x plus cos x the whole square dx plus integral 0 to pi by 2 cos x upon sin x plus cos x the whole square dx. As you can see, the denominator of both the integral is same. Therefore, we can directly add the numerator. Here, 1 sin x plus cos x will be cancelled from numerator and denominator, and 1 upon sin x plus cos x will be left. Now you can see that the given integral is in the form of 1 upon a sin x plus b cos x plus c. We have seen this type already in the previous chapter, that is integration. In this case, we need to put tan x by 2 is equal to t. The value of dx will be 2 dt upon 1 plus t square. The value of sin x will be 2t upon 1 plus t square, and the value of cos x will be 1 minus t square upon 1 plus t square. And after the substitution, we need to change the limits. The previous limits of x were 0 to pi by 2. If I substitute the values of x as 0 and pi by 2 in the first substitution, x is 0, therefore this becomes tan 0, and the value of tan 0 is 0 only. But if I substitute x as pi by 2, so pi by 2 upon 2 will give you pi by 4, and tan pi by 4 is 1. Therefore, the limits of t will be 0 and 1. This will give you 2i is equal to integral 0 to 1 upon the value of sin x is 2t upon 1 plus t square plus the value of cos x is 1 minus t square upon 1 plus t square into the value of dx is 2 dt upon 1 plus t square. As the denominator of these two fractions is same, we can directly add the numerator, and we have integral 0 to 1 upon 2t plus 1 minus t square the whole divided by 1 plus t square, and hence 1 plus t square will be cancelled. Taking these two outside the integral, we have 2 integral 0 to 1 1 upon 1 plus 2t minus t square dt. Here 2 will be cancelled and the integral is in the form of 1 upon quadratic. Now to find the integral of 1 upon quadratic, we need to find third term first, and for that the coefficient of t square should be 1. As you can see, it is already 1. Therefore, third term is given by half into coefficient of t the whole square. Coefficient of t is 2. On cancelling 2, we have 1 square left, which is equal to 1. Now we will give the negative third term to t square as its sign is negative, and add the positive third term in the starting only. This will give you integral 0 to 1, 1 upon 1, giving the positive third term plus 1, balancing it by minus 1, and further we have plus 2t minus t square. 1 plus 1 will give you 2, and minus will be taken common from all the three terms. This will give you t square minus 2t plus 1, which can be reduced as t minus 1 the whole square. And at the same time, we can write 2 as root 2 the whole square. To find the integral of this expression, we can compare this integral with the standard form of integral one upon under root a square minus x square will give you sin inverse x by a plus c. The value of a will be root 2 and the value of x will be t minus 1. Therefore, we have I is equal to sin inverse of t minus 1 upon root 2 within limit 0 to 1. Now let us substitute the upper limit and the lower limit. This will give you sin inverse of 1 minus 1 upon root 2 minus sin inverse of 0 minus 1 upon root 2. 1 minus 1 will give you 0, 0 upon root 2 is 0. Therefore, we have sin inverse of 0 minus 0 minus 1 will give you minus 1 by root 2. This minus will come outside and minus into minus will give you plus. Sin inverse of 0 is 0. Sin inverse of 1 by root 2. In sin theta, the value is 1 by root 2 only when theta is pi by 4. Therefore, sin inverse of 1 by root 2 will give you pi by 4. And 0 plus pi by 4 will give you pi by 4. This is our final answer. I hope friends you have understood this problem. Thank you for watching this video. Stay tuned with Ekeeda and subscribe to channel Ekeeda.